Okay, how are you guys today? I'm sorry for taking so long with some of these examples. The whole thing is more complicated than I initially thought. But anyway, I do want to help you out a little bit more so that for your homework you would have a little bit of additional information. First of all, let's look at this example. This is actually on some of the exercises after the chapter. This is exercise number 8. Some individuals prone to violence are not men who treat others humanely. Some police officers are individuals prone to violence. Therefore, some police officers are not men who treat others humanely. Now, suppose you are given this categorical syllogism. What do you do? What is the process? Let's try to do it together from the beginning and see exactly what are the steps to evaluate it and see whether it is valid. First thing you need obviously to do is to get your form, the form of an argument. What are your terms here? Well, obviously individuals prone to violence would be one term, and that would be I. You can call it I. You can call it anything, but let's call it I. Then this is the word which connects it. Are not, actually two words. Are not men who treat others humanely, that would be the second term, and let's call it M. Then some police officers, that would be the third term, and we'll call it P, and the rest of them obviously are another occurrences of the same terms. So this here would be I, right, individuals prone to violence, and this here would be P again, police officers, and finally men who treat others humanely, that would be again M. So the form of this argument would be some I are not M, some P are I, and the conclusion is therefore some P are not M. Now, you get the form. What do you do now? This is actually kind of a complicated example, so it's a good one to address. Now let's take a look. First of all, where do you start? Of course, you don't have any universal premise, so you just can start on top. You do your three circles. Just get some space here. So all right. Yes. So this is our three circles. What do we name what? Well, the first step is super easy. You just look at your conclusion, right? And this will be P and M. You just copy it from the conclusion. Then what's your middle term? Obviously it'll be I, so this would be I. Then you start here, and what you need to do is you need to represent some I are not M. Now, just to decide for yourself, you can look at it as two circles, something we did in chapter 4, right? I and M. And what do you do to show that some I are not M? You'll put an X here. Nice. Okay. So you put an X there. Now you need to transfer it here. And this is where some students kind of make a mistake. Because note that the area where the X is in is this whole area here, right? This is all this empty area where the X is in. Where is it on that circle? Here. So when you have something like this and you have a line going through that, your X should actually go on that line, right here, to show that you don't know on which side of the line it is. Okay? So this is where the correct position of X is. Now, next step is, of course, your second premise, some PRI. Now, for this premise, you do exact same thing. You again have the two circles to the side, P and I, right? And then normally you would put an X here, right? So this is your area of interest, this whole area between them. And here's your I, here's your P. This is the two circles. So what's the area of interest in this case? That area, right? You can see that. That's the area. But again, you have a line going through that. So again, you have to put your X on a line. When you put in an X on a line, essentially what it tells you, it could be on this side or on this side. On any side. And it is crucially important. Because look at the conclusion now. Some P are not M. So ideally, what should you have for this conclusion? You should have the picture like this. So your X should definitely, and without any doubt, be inside this particular area. Is it? Where's that area here? Well, this is the area. But note that you actually don't have any X's definitely there. You have two X's on the line, but they could just as easily be here. When you put it on a line, it means either here or here, either here or here. And that is a crucial difference, because that actually makes it invalid. Because you don't know. There is a good chance neither of these X's is where it's supposed to be. And then it would be invalid. And remember, it's strict necessity. It has to definitely be there. Okay, now let's move on to the Aristotelian standpoint. Okay, so now that it is clear for us where do we put an X, we have to go back to where I left off from the last lecture and look again at the Aristotelian standpoint. What is the Aristotelian standpoint? Again, hopefully you understood it from chapter 4. I do not have time to go through it in as much detail now as I would have normally done in class, because in class when we go over chapter 4, I actually spent quite a bit of time explaining the difference between Boolean and the Aristotelian standpoint. Now I can only assume you got it for yourself. If you didn't, send me a message or something. I'll try to help you, but I really don't have time now to repeat several lectures from the last week. I'm having trouble enough as it is to squish all these lectures which we have until the end of the semester on time for you. So anyway, suppose we have something like this. The example in the book is no fighter pilots are tank commanders. All fighter pilots are courageous individuals. Therefore, some courageous individuals are not tank commanders. So I already extracted the form. No F are T, all F are C, some C are not T. We can draw the circles. Nice and big so you could see them well. Okay, what do we do next? Well, remember, we have to check and make sure that we have a universal premise there. Yes, they both universal. We can start on top. That is good. There's no problem with that. Now, let's fill it in. So again, this will be our C, this will be our T. Just look at the conclusion and it tells you immediately what is this circle, what is that circle. F is whatever is left will be here. Right. Next you do no F R T, so you just basically shade the area between an F and the T. Lovely. All F are C, so now you would have to shade the entire F outside of C. Right, okay. Now you look at it from the Boolean standpoint. Clearly from the Boolean standpoint it is not valid, because for some C are not T, you actually need to have an X here, right? This is what you need. You don't have an X there. Alright. This X can be anywhere, note, in that area here. But it has to be an X. Now we move on then to the Aristotelian standpoint. Few simple rules which you have to remember for investigating Aristotelian standpoint. First of all, both of premises has to be universal. They have to be universal. They cannot be particular. So you have to go from universal to the particular. That's the only time you can really use Aristotelian standpoint. If you have one of the particular premises here, such as some f or c, that's not going to be good enough for our investigation from Aristotelian standpoint. Okay, we do have that. We have universal premises, particular conclusion. Right. Then you're looking for one circle which is all shaded but one area. Which one is this? Well, obviously that would be an F circle, because with a T circle, usually only part of it is shaded. But with an F, almost all of it is shaded. So this will be your critical term then. The circle which you assume in existence, the circle which is all shaded but one area, that is the critical term. Now the next step would be to assume existence of this term, which is basically to put an X here with a circle. Now that means we're now saying that we do know there is at least one thing here. And then you do the same thing as you did to evaluate it before. You need this picture somewhere note that this is the area, right? Somewhere in this area there should be an X. Oh, look at it, now there is. There actually is an X. It doesn't matter whether it's here, as long as it's within this area. And how do we know this area? Well, it's an empty one. The entire thing is empty here where we have an X. It's like, well, not empty because we have an X there, but it is this whole area which has no lines or anything. Okay, so now it is conditionally valid. But what's the condition? The condition is we assumed existence of something. What is it? Well, we actually are in luck, because remember, if it was just an F, then at best we could say it's conditionally valid on whatever is F actually does exist. Because we don't know F. What is F? We don't know. But in this particular case, remember, we just got this form from an example. An example actually tells you no fighter pilots are tank commanders, blah, blah, blah. So we know what F is. F is fighter pilots. Do they exist? Yes. So for this reason, it is valid from Aristotelian. Again, remember, when we assume an existence of something, we're doing so provisionally. But then we can use our knowledge of the world around us to actually evaluate that and find out whether this thing actually exists. This is one of the reasons actually why we have this difference between Boolean and Aristotelian. Boole came up with this stuff in the 19th century in order to simplify Aristotle. Aristotle was the one 2,400 years ago who came up with the whole thing, and he actually did make this difference between things which do exist and things which do not exist, which gives us a lot of good relations. Now Boole simplified it, but he also took away all these complicated relations, which makes it harder for us to evaluate some arguments. So from Boolean standpoint, we don't even know if it's a valid argument. We can only know it from Aristotelian. For this reason now, it actually is a little bit more complicated because we learn both Boolean and Aristotelian. But the point of Aristotelian standpoint is this. Some things do exist, some things don't. If you talk about things like unicorns or some other imaginary creatures, then you cannot assume their existence because they actually don't exist. However, with certain things such as fighter pilots, you can assume their existence because they actually do exist. So not only can you assume it, you know they do exist. And that makes our job hell a lot easier, because if this field is empty, what it tells you is you don't know if there's anything there. But if we're talking about something like fighter pilots, why wouldn't you know that there is anything there? You know there are fighter pilots. I know that. Everybody knows that. There are fighter pilots. It's not, some sort of nuclear science to find out whether they actually exist. Of course they exist. And so for this reason, that whole thing is quite a bit more clear to us. And we can say, yes, it is a valid argument. Of course it is a valid argument. But remember again, that is only if you have both universal premises, because you actually need this stuff to be shaded. Every time you put in an X, you put in an X to the circle which has everything shaded but for one part. And that is the circle which existence you assume. So once you have done your work here, if you need to find out whether that thing actually exists, You have to look at whatever you assume the existence of. Okay, hopefully that finally cleared up the entire chapter 5. And tomorrow we can move on to chapter 6. I will try to put up lectures on chapter 6 on time, so you actually have them as we go along, rather than pile them all on the weekend, because finally I have all this equipment and I can put it all together and I can give it to you guys, and hopefully you'll be watching it too, because I can see that a lot of people did watch it for like 3 or 4 minutes and then kind of stopped, and this is not very helpful, of course, to them. Well, if that's your choice, but I mean, I know that this is a difficult stuff to understand if all you rely on is the book, and this is why we have on-site lectures, but unfortunately in this current environment we cannot have that. So please stay safe, do all the homework. Next week we'll move on to chapter 6. I'll give you more information and hopefully explain these things more clearly. I also am getting a little bit better at talking to the camera. I kind of get a better grip on it, so to say. So hopefully you'll see it too. You'll see improvement in terms of lighting, whatever other things. Okay, so I will try to upload it right now so you would have it in time for the homework. Until next week.